Measurement and Experimentation Part 1. In this video, we will learn about measurement, purpose of measurement, units, definition and types, system of units, their brief description and classification, fundamental units, their definition and properties, and prefix used before units. So at first, we start our topic. Before that, we have to know that what is a physical quantity. A physical quantity is a quantity that can be measured. For example, length, mass, time, temperature. These all things we can measure. A physical quantity is always measured of natural non-living objects. Yes, these all are natural, but these are non-living objects. It have a numeric magnitude and a unit. Now we will learn measurement of physical quantities. Here we will start our topic. So what is measurement? It is defined as the process of comparison of the given physical quantity with a known standard quantity with the unknown quantity of the same nature. If we consider an example, for example, your mama goes to market to buy some sugar. So what the shopkeeper does? He has some weights of standard measure. For example, or consider that your mama wants to buy 1 kg of sugar. Then what the shopkeeper does? He uses one weight of 1 kg, that is standard. He uses that weight on the one side of the balance and the other side he keeps the sugar until the two weights become balanced. Then only he came to know that yes, it is 1 kg of sugar. This means that he is comparing a quantity with a standard quantity of the same nature. This is known as measurement. I hope it is clear to you. The standard quantity used to compare the physical quantity is called units. For example, if your mama want to buy 1 kg of sugar, here 1 is the numeric value and kg is the unit. So, kg is a unit that is used to measure mass. It is not used to measure any other physical quantity. So, from here we can get one property of units, that unit is a standard quantity that is used to measure physical quantity, or that is used to compare physical quantity of the same nature or the same type. A measurement leads us from an unknown to known situation. For example, when you go to market to buy 1 kg of potato, so you don't know how many potato or how many grams or how many numbers of potato will make 1 kg. So it is an unknown situation, but after buying the potato, you come to know that yes, this amount of potato is 1 kg. So it leads us from an unknown to known situation. I hope you have understand. Next, important notes. In any measurement, numerical magnitude is inversely proportional to the size of the unit. That is, N1 U1 is equal to N2 U2. So it is in terms of very difficult English. So in simple, we can say that in any measurement, the numerical value is inversely proportional to the size of the unit. For example, 1000 meter. 1000 meter is equal to 1 kilometer. So here 1000 meter, here in case 1000 is bigger, but meter is a smaller unit. But 1 kg here 1 in terms of numeric value, 1 is 1000 times smaller than 1000. But here 1000 meter is equal to 1 kg. Here, though the value of 1 is smaller than 1000, but here it is in upper limit. So we can say that numerical value or numerical magnitude is inversely proportional to the size of the unit. Next, physical quantity has two magnitudes. As I have told earlier, it has numeric value and into unit, or numeric value and unit. Next, any physical quantity with no proper unit has no value. Yes, it is true. To consider this, I have given you two instructions. There are two circles. One of radius 5 and one of radius only 2. Now I have asked you the question, which one is bigger or which one is smaller. So it is very difficult to determine it, which one is bigger, which one is smaller. In terms of unit, the 5 may be 5 millimeter, or the 2 may be 2 meter, or it can be 2 centimeter, 5 meter, and so on. So we are confused that which one is smaller or which one is bigger. So any physical quantity with no proper unit has also no value. Physical quantities and measurement and their classification now. It is divided into 3 parts: basic and derived quantities, scalar and vector quantities, and vector multiplication. So again, basic and derived quantities are subdivided into unit conversion. Scalar and vector quantities, they are again subdivided into addition, subtraction, and vector resolution. And again, vector multiplication is subdivided into scalar and vector products. But here we will only concentrate, or we will only focus on basic and derived units and unit conversion. Now, fundamental quantities, the physical quantities which do not depend on any other physical quantities for their measurement, are known as fundamental quantities. For example, in case of biology, cells are the fundamental quantities of our body. It is the single unit. It is not dependent on any other quality. But a number of cells combines and forms a multiple tissues. That tissues form organ system, and that organ system form organs and an organism. So in case of physics, quantities which are not dependent, or which are the basic or the fundamental or the primitive quantities, they are the fundamental quantities. For example, mass, time, length, temperature, these are primitive. They can't be subdivided, or they are not dependent, or they are not made up of any other physical quantities. Thus they are fundamental quantities. Next we will learn derived quantities. Derived quantities are those which are derived, or which is a combination of 2 or more primitive quantities or fundamental quantities. You can understand from the example. For example, area. Area is length into breadth. Here both length and breadth are types of length. This means that without length we can't define an area. Other than area, some of the derived units are volume, acceleration, retardation, momentum, velocity, density, etc. Now, system of unit. Before we start system of unit, let us learn some historical background of it. In the beginning of the civilization, when people felt the need of measurement, they used various parts of the human body as unit. For example, an foot length, an arm length, etc. was the various unit of length at that time. The length of Henry Ford's full stretch right arm from his nose to the tip of the middle finger was considered as 1 yard. The smallest unit to measure mass of any object were known as reti, a rate. The sand clocks was used to measure time. In the beginning of the 20th century, the following 3 units were practiced: centimeter gram second, that is the CGS unit; foot pound second, APS unit, also known as the British unit; meter kilogram second, or MKS system. But these units were not widely used, so there was bitter confusion. So, in a meeting in Paris, 1916 introduced International System of Unit, or commonly known as SI unit. In SI unit, the following several basic physical quantities are given that are internationally accepted unit. The selection of SI unit are on the following properties. Number 1, the unit should be of convenient size. Number 2, it should be well defined. Number 3, the unit should be reproducible. Number 4, the value of unit should not change in different frames of reference. So, the fundamental and basic units of SI we will learn in the next video. Up to this, we will learn today. Now, let us discuss the summary what we have learned today.